All right, let's dive into Apache Spark's GraphX library. If you've ever found yourself wrestling with complex data relationships, we're going to look at the fundamental building blocks that give you a much more powerful way to think in graphs. You know the feeling, right? If you come from a relational database background, this is a classic pain point. Trying to figure out something like friends of friends on a social network, well, it can turn into a complete mess of SQL joins. It just doesn't feel natural for that kind of problem. So what's the solution? Well, it's really about shifting how we look at the data. On the left, you've got the world you know, tables, rows, connected by foreign keys. But on the right, we have the graph model, which uses a whole new vocabulary. Here, our data points are called vertices, and the connections between them are called edges. It's a model that's literally built from the ground up to understand relationships.
Okay, so let's drill down into that. To really get a handle on GraphX, you've got to get comfortable with these two core ideas, because they are truly the heart and soul of any graph.
A vertex, it's just a thing, an entity. It could be a person on a social network, a product in an online store, or maybe a research paper. You can think of it just like a row in a database table. It holds all the data and properties for that specific item. It's the what in our graph.
And you know, creating them in Spark is actually pretty simple. What you're seeing here isn't some new complicated graph object. Nope. It's a good old resilient distributed dataset, or RDD, the bedrock of Spark. Each piece of data is just a simple tuple with a unique ID and then the data itself, which in this case is just a name.
So, if vertices are the what, then edges are the how. An edge is the actual relationship that connects two vertices. It's the is friends with link, or the like status action. And this is really important. The edges themselves can have their own data, like a rating or a timestamp.
And again, in the code, creating an edge RDD is just as easy. You're just defining an array of these edge objects. Each one spells out where it starts, the source vertex ID, where it's going, the destination vertex ID, and what the relationship is. So right here, we're saying vertex 1 is friends with vertex 2. Simple as that. And this really brings us to the core idea of GraphX. It's not magic. You just take your collection of vertices, your RDD of things, and your collection of edges, your RDD of relationships. You put them together and voila, you have a graph. The entire massive, complex network is built from these two surprisingly simple distributed datasets. Okay, but if you're coming from that database world, I bet you're wondering, what about primary keys? How in the world does the graph know which vertex is which, especially when everything's spread out across a cluster?
The answer is something called the VertexId. And honestly, you can think of it exactly like a primary key. It's that unique identifier that guarantees we can find any specific vertex in our graph, no matter how ridiculously huge it gets.
And believe me, GraphX is built for scale. That vertex ID is a 64-bit long. That gives you enough unique IDs to model graphs with, well, quintillions of nodes. That's more than enough for pretty much any web-scale problem you can throw at it.
So we've established that a graph is just a vertex RDD and an edge RDD. But why does that matter so much? Why is that specific structure so darn powerful?
Well, this is the secret sauce. By building on top of RDDs, GraphX gets all of Spark's superpowers for free. Your graph is distributed by nature, which means it can be sliced up and spread across a whole cluster of computers. It's fault tolerant, so if one of those computers goes down in the middle of a big calculation, the system just recovers and keeps going. And it's immutable, which means you get more reliable, predictable results.
So here's the bottom line. The entire design of GraphX, from the vertices and edges all the way down to its foundation on RDDs, is engineered for one thing: analyzing relationships in absolutely massive datasets. It's all about getting past the limits of tables and rows so you can understand that rich, complex web of connections hiding in your data. And that's our quick tour of the fundamentals. If this explainer helped clear things up for you, do me a favor and hit that like and subscribe button. It genuinely helps more people find this content and keep on learning. So we've covered the building blocks, we've covered the core ideas. You now have the foundation to start thinking about your own data in a whole new way. The real question is, what amazing relationships are hiding in your data, just waiting for you to find them?